I am Chuck Gulash, and what we really would like to do today is have you learn about CSRC by providing an overview of our first year of activities. But we'd really like you to engage with our engineers, our researchers, our partner from the universities, and exchange ideas. And so the time that we've got allocated for this program is really devoted back in the specific displays. And we also want you to hear about our future projects. So for background, Akio Toyota at the North American International Auto Show last January 2011 made the announcement of the creation of CSRC. And the intent is to work with leading North American universities, research hospitals, agencies to advance the research for automotive safety. And at the same time, do it to benefit the entire industry and society. And we're estimating that the funding for this over a 5-year period is $50 million. The vast majority of that $50 million is going to our collaborative partners. The right side of this slide gives you an idea of our approach. Typically, our research, not only at Toyota but at other OEMs, is based in the lower left quadrant, where it's done proprietarily or it's done internally or for the unique position of Toyota. And we're still doing some of that research, but CSRC from the start is positioned in the upper right quadrant, to be open, external, and benefit industry and society. And we're building in to our research contracts, statements of work, how the information is going to be shared, either models that show up on our website or data that shows there or just sharing in technical conferences. We have 3 pillars that make up CSRC: collaborative research, crash data analysis, and outreach, which is actively sharing the information. And so I'll give you a little bit of insight into those 3 pillars. And before I do, I want to just share with you where our focus is. Active safety, distraction, and areas to help these vulnerable populations. There's many vulnerable populations, but we are focusing on children, newly licensed teens, seniors, and pedestrians. Some of the reasons why we are doing that are shown in the next few slides. Traffic fatalities among children 14 and younger over the last 10 or so years are shown here. It's been pretty stable for 7-year-olds and under, and there's been some drop, 8 to 14-year-olds. But this data comes from the Center for Disease Control last spring, and it's the unintentional injury deaths by age group and mechanism. And you can see that the blue segments of the bars are motor vehicle traffic related. Others are things like suffocation, drowning, fires, and the 1 to 4-year-olds, it's a part of the unintentional deaths. But once you get to 5 and beyond, it becomes the predominant mode of death. And what struck me when I was putting this together was the big jump to the 15 to 19-year-olds in terms of volume. This was for 1 year, 2009. But these are reasons why we chose children and teens. Also, this chart from NHTSA from a couple years ago shows that the number of drivers that are involved in fatal accidents per 100,000 drivers is heavily skewed toward the younger driver population. There's a silver tsunami that's happening. There's an increasing number of 65-year-olds in developed countries around the world, but you can see here in the U.S. we're roughly 13–14%, 65 and older, growing to 21% by 2040. Canada, a little bit above that. But Japan right now already is at 23% and forecast to grow to 35%. So the senior population is not only important here, but also elsewhere around the world. And I attended NHTSA's older driver workshop a couple of weeks ago and learned that we're really at the front edge of a 20-year trend where 10,000 people a day are turning 65 years old. So seniors are part of our focus. This is the bathtub curve that IIHS prepared a couple of years ago, but you can see on both ends, there's risk. But when you get to 79 and 80, per 100,000 miles driven, the fatality rate goes up for those drivers. Pedestrians are also an issue. Typically 11 to 12% of the fatalities in the U.S. Are pedestrian related. I think this is growing more closer to 13% or maybe even 14% today. So pedestrians are important here, but also elsewhere in the world and even the developing countries. But there was an interesting crossover point that happened in 2009 in Japan. More people were actually killed outside of the vehicle than as occupants of the vehicle. So pedestrians are also a very important issue in Japan. So let me just move along a little bit to some of the philosophy of our portfolio. We've modeled this very much related to the thoughts of Dr. Haddon. Maybe many of you knew him or have heard of him, but he was an epidemiologist, and he was the first director of the National Highway Safety Bureau. And in a late 60s DOT conference, presented the Haddon Matrix, where from an epidemiological perspective, he looks at some event happening, in this case in the automotive world, a crash, and there's things leading up to that event and things after that event might be done to either eliminate it from happening or mitigate the consequences. And the domains that you could perhaps have interventions include the human, the vehicle, and the environment. Toyota, like other OEMs, looks at the same domains: people, vehicles, and the traffic environment. And for last 5 or 6 years, we've been talking about our integrated safety management concept, and this is really looking at a series of product-related activities that we do, from a parking to active safety to pre-crash, passive safety, and post-crash. But when you put those two things together, it becomes a modified Haddon matrix. And one of the reasons why I call it a modified Haddon matrix is I think that there's an important additional column on pre-drive culture that we've put into here. But I use this to share with our potential research partners where we're interested in creating research projects. And so in 2011, we developed 19 projects, 10 of which are pre-crash related, vehicles and people, and 9 of which are post-crash. And typically our research contracts are 2 to 4 years. Some of them are longer, as many as 5 years. And in the first year we've had 10 research partners. There's a great story and great activity behind each one of these projects. I have them sorted here by human factors, active safety. The blue boxes on the left are indication of the ones that we're going to share in more detail with the researchers later and in the back of the room. We also are doing biomechanics and human body modeling projects and some post-crash projects. And our business model is set up so that we don't have open calls because we don't have the resources inside to properly assess them. But we generate some of the ideas and for research projects, we're looking for gaps that may exist in longer-term research programs. We're also really trying to build on research that has gone before us. NHTSA, Federal Highway, TRB, many sponsorships, we're able to, with our partners, build them, to the next level. So that's a quick review of the first pillar. The second pillar is crash data analysis. And Toyota looks beyond regulations. We look to the real world to improve our products, and we're continuously striving to improve them by starting to look at crashes, investigating them, looking for some of the root causes of injuries, and then simulating those in the laboratory or on the computer, and then taking that information and trying to develop products that help address those. And we evaluate those and just take this cycle on a continuous basis. So CSRC is aimed at improving our knowledge of what can be learned from crash data. And we're looking at not only existing data sources after the crash, from NHTSA, from information that can be found from event data recorders, but we're also looking at the new data sources, the naturalistic driving studies that are underway. And we've got some guests here from the Transportation Research Board. TRB is sponsoring from Congress a multi-year naturalistic data study, SHARP-2, that is the largest in the world. And it's intended to contribute to the automotive research in a number of ways for maybe over a decade. But there's 3,000 personal vehicles that will be equipped in 6 different regions of the country with video cameras and other sensors. And people in their normal driving environment, will be providing the information. Virginia Tech Transportation Institute is storing that data, and they're helping to manage that. But the video from that project alone is projected to be over a petabyte. And it's hard for me to imagine a petabyte, but I did some calculations, and if we were to engage one undergrad to look through the entire petabyte of video data, she would be watching this for 13.3 years. So we're also looking at developing tools, to help to analyze some of this data as part of the CSRC projects. So that's the first and second pillar. The third pillar is outreach. And I think it's important that we actively share. Yoshida-san, talked about the importance for Toyota Motor Corporation to make this research transparent and available. We're doing this in a number of ways. Brian talked about going live with our revised CSRC website today. We're going to continue to build on it. One of the reasons we've revised it is as we start to get some of the results from these projects in, we're needing to be more robust to be able to share that information and have it out in the research community. But we're also engaging with our research partners and asking them to contribute not only the research from here, but maybe links to other researchers that they're doing so that it can be shared with more people. So for just a couple of quick updates, I've picked out 3 active safety projects just to give you a feeling, give you a taste for the kinds of things that's going on. One from Virginia Tech on lane departure warning, one from UMTRI, the University of Michigan Transportation Research Institute, on pre-collision system target development, and then one from TASI, which is the Transportation Active Safety Institute, and that's part of Indiana University, Purdue University at Indianapolis, and they're looking at PCS from a pedestrian perspective. So just a little bit on the LDW at Virginia Tech. They're the lead partner. They're doing a sequence of activities, and many of our projects, have the same sequence, looking at the crash data, understanding the current situation before moving on to scenario identification and simulations. But this project will also use some of the SHARP-2 data in the future. And there's 3 tasks: looking at the microanalysis of crash patterns, developing methodologies to estimate the safety benefits, and then actually simulating those. And the task 1 is looking at detailed crashes. Also, Virginia Tech has the ability to, and Clay Gabler is the PI, to take a look at the event data recorder information, and then also a special NAS study. And so what's been found so far is lane departures themselves represent about 40% of the particular lane departure crashes. And we've chosen lane departures as a focus area because it's the largest single type of crash that's causing fatalities and serious injuries in the U.S. And we've broken it down a little bit more, and 32% of the crashes that Clay has looked at happen on straight roads. This is lane departures, and 21% on curved roads with departures to the right. And you can see some of the distributions for the other styles. So we're using this information to help the simulation, but we're using it to help improve designs and programs that we've already got within Toyota ourselves. The median departure speed was 49 miles per hour, and the median angle of departure was 10 degrees. This makes some difference when you're looking at lane departure warning or lane departure prevention sensing systems. Also, Clay looked at pre-crash speeds. This is from event data recorders, that 29% of the vehicles actually accelerated before the incident, 6% no change, and about 2/3 decelerated. About a fifth braked 1 second prior, and 45% didn't brake at all. So we're building all of this into the further stages of the research, but also we're sharing this data in technical conferences. Another research theme was the PCS target development. The intent of this is to contribute to the body of knowledge of how to evaluate pre-crash systems. And UMTRI is doing that also with the assistance of Michigan Technical Research Institute. Michigan Tech is in Houghton, Michigan, but this activity is in Ann Arbor. And they were chosen because they've got expertise on W-band radar, and they've built that into our projects. Again, we've gone through we're going through 3 steps. We're really in the second step phase right now, and from the first task, identified LV as lead vehicle of a rear-end crash. Almost 2/3 of these crashes were when the lead vehicle had been stopped. 26% was when it was decelerating. But we also found, and they had EDR data for both vehicles on a fairly small number of cases, but 40% of the following vehicles never braked before the collision. This is just a couple of pictures of the radar setup that was done at Umtree, and there was 30 different measurements taken on about 30 vehicles, and that information, you know, we're sharing with agency people, we're sharing with NGOs, and we're also sharing it at technical conferences. And then just one brief more description on the work at TASI, and it's on target and test procedure development. TASI is also engaged with the Ohio State University. Ohio State University is doing radar signatures of human subjects, you know, to help understand and develop that knowledge, and they're really just getting underway. We're, you know, basically approaching it in the same sequence, and a unique part of this project is that TASI has engaged 100 vehicles in the Indiana area with video cameras. And so we're looking at pedestrian actions. And so what we want to do is not only simulate how they walk, what the gait is like, but we also want to be able to understand, you know, unique actions so that we can design better sensors and better identifications for pedestrian PCS systems. For the radar aficionados in the crowd, you know, this is the plot for the radar cross-section, the RCS, and the blue lines show what a radar would look like for just a standing person. The red line shows what it's like for a running person. So we're going to be doing more and more of these to help understand you know, those different modes of identification. So next week, for example, they'll be up in Anchorage sharing some of this data at the ITSC. So I'm just kind of wrapping up the introduction and the updates for you. But besides learning some of those technical knowledge, we're seeing some other things that are happening, some things that we really couldn't fully predict a year ago. But I do have one more thing. We are broadening the scope of the research portfolio for CSRC. We are moving to the left. We're moving more towards some of the pre-drive culture kinds of activities that you know, Tina and Jean Shope are doing, for example, in the teen surveys. We have some new second wave partners: Stanford, University of Toronto, University of California, San Diego. We're going to the Aging Mind and Brain Institute at the Iowa Medical School. And I don't know how well this is going to work out, but we're actually bringing together Virginia Tech, University of Michigan, and the Ohio State University on a project. And so we'll see how that goes, because there's some internal betting even within TTC on how well that will do. But we've got great projects in the first wave, but we've learned a little bit, and I think we've got, you know, some outstanding concepts to look at for the second wave. At Stanford, we'll be working with Cliff Nass and looking at partially intelligent vehicles and driver interfaces and how to maintain situational awareness for drivers as we head more and more to driver assistance systems. At UCSD with Mohan Trivedi, we're looking at it's somewhat of a risky project, but if it pays off, it's automated tools, to look at the naturalistic driving data. A big thing that UCSD has been doing over the years is looking in the vehicle and looking out. And so we'll tap into their expertise and build a toolbox, actually, that other researchers that'll be able to use to look at naturalistic data. With Matt Rizzo at the University of Iowa, measuring the use and impact of in-vehicle technologies on senior driver safety. We've talked about the teen driver survey at UMTRI. At the University of Toronto with Burson Donmez, looking at feedback to help induce safer driver behavior on risky drivers and not so risky drivers. We're going to extend the lane departure warning to a lane departure prevention activity, and that'll be done across Virginia Tech, UMTRI, and Ohio State. And we've teamed up with NHTSA and SAFER, which is a Swedish organization, to sponsor a study at Children's Hospital of Philadelphia looking at mild traumatic brain injuries on youth hockey teams. So we're looking at a couple more for the second wave, but we don't have anything in place at that time. So with that, thank you very much, and have a good day.